Good afternoon. Our lesson for today is about the parts of the circle. So I'd like to introduce to you the shape of the circle will look like this. Okay. So first we call the length of this one. The length of this curve is what we call an arc. Okay. Now we have the center of the circle and we will denote that as point C. Now if this is the segment, if this is the arc of the circle, when we connect two radii, okay, when we connect two radii here, take note, radii is the plural of radius. So singular, we call it the radius. For the plural term for radius is radii. So when we connect two radii, the area bounded by this arc and the two radii is what we call the area of a sector. Okay, again, by definition, that an area of a sector is bounded by an arc, is bounded between an arc and two radii. This is what we call the area of a sector of a circle. So we call this one as your radius R. Okay, we got the center here, and the double of radius is what we call the diameter. Meaning, this is the diameter, and half of the diameter is what we call the radius. Take note of that. So it can be written mathematically that the diameter is twice of radius r. Take note of that. Next thing is that we call this diameter the longest chord. Take note, we call this as diameter d, or we can also call this as the longest chord. Why is it so? A chord is defined a line that touches between two points on the circle that shall be drawn inside of it. So this is what we call the chord. Okay, we will call this as the line segment named chord. So this is also a chord because it connects two points within the circle. Okay, this is the longest chord. We call this only a chord. Also here we can call this as connecting these 2 points between 2 points here. We call that as a chord. Now, previously we have defined this area as the area of a sector of a circle. Now when we introduce a chord here, and the area for this only, or this part, is what we call the area of a segment. So take note of the difference. The entire area, which is shaded in blue, is what we call the area of a sector of a circle, and this shaded area that is in red is what we call the area of a segment. It can be shown mathematically that to get the area of the segment is the area of this, okay, we will write it this way, that the area of a segment is equal to the area of this one. What do you call with this one? The area of a sector minus this one is this one, correct? So the area of the sector minus the area of the triangle, that can be denoted as like this, is defined as the area of the segment. Clear? Okay, we will pause the video for a while. Okay, we will resume. Now, we were able to put different parts of the circle. I'd like to add more, which are the tangent line and the secant line. So we will just draw another circle, just not to complicate the drawing that will make us confused. So I will draw another circle here. Okay, so again we get the centers of the circle here, C, and we have this line that only touches at one point. This is what we call the tangent line. Okay, in which if we are going to connect from the center to the point of tangency, we call this as the point of tangency. So when we are going to connect this one from the center to the point of tangency and this tangent line, the relation between these two, or the angle formed between the tangent line and the radius intersecting at point of tangency, is 90 degrees. Always the tangent line is perpendicular to the radius r. Okay, so if a line touches at one point, we call this a tangent line. So what about a line that passing through the circle at 2 points? Okay, we call that as a secant line. Clear? Now, if a line does not go through and through with the circle, we call that what? As what I've said dito, anong tawag dyan? Pag gumawa lang ako ng line dito, going here, we call this one as a chord. Claro? So, if I make a chord passing through the center of the circle, this is the, here, at this point, passing through the center of the circle, we call this as the diameter, and again, we call this the longest chord. Clear? Okay, continuing. So we were able to discuss a lot of parts of the circle. So we got the radius, we got the diameter, we got the area of the sector, we have the part of this one which is shaded in red, the area of the segment, and the longest chord is the diameter. This is a chord. We have the tangent line, which is defined as a line that touches at only one point on the circle. Okay, we call that the tangent line. And the intersection between the tangent line and the radius, is what we call the point of tangency, which forms always 90 degrees with each other. And then we call this again the longest chord, the diameter. Half of the diameter is the radius. A line passing through the circle, which is this one, we call the second line. When it is only this one, what do we call this one? It's only a chord. Paglagpas, it's a second line. Clear? Now next, maybe you will ask me, sir, what's the area of, you said that area of a segment is the area of a sector minus the area of triangle. So, what's the formula of the area of a sector and what is the formula of the area of the triangle? So, that will be discussed next. Okay? So, first, area of a sector. So, area of a sector, okay, what is this again? We will define again. In the figure, it is bestly represented as 2 radii, okay, and the arc. So the area bounded by the arc and the 2 radii is what we call the area of the sector. And then you will ask, sir, what is the formula for that? What's the formula for this area? So it is defined on the first page as to find the area of a sector of a circle, get the product of the ratio. So when we talk about the ratio, it is the ratio between the measure of the arc over 360 degrees and the area of the circle. So we will put that into mathematical equation. How does it look like? So area of the sector is equal to the ratio. Take note, area of the sector is to get the product between the ratio of the arc over 360 and the area of the circle. So, first, ratio. So, over 360. Measure of the arc. The measure of the arc is defined to what we call the extent. To what extent is the arc being expanded? And that is very dependent on what we call, which is this angle. We call this as the central angle. It means to say, the more the central angle you will have, the more length of your arc will be. So it is said, defined, that the area of a sector is the product between the ratio of the arc, the product of the ratio of the arc and the area of the circle. Take note, area of the circle, anong formula? Area of the circle is pi r squared. Clear? So it follows that the formula is this one. So ibig sabihin, if the central angle is 30 degrees, it means to say the ratio is 30 over 360 degrees, 30 degrees, times pi r squared. So 0 is cancelled, 3 over 36. So it means to say you will have 1 over 12 of the area of the circle. It means to say 1/12 of the entire of the circle is this area, which is the area of a sector. We will try to check. The area of the circle, as we said, that area of the circle is pi r squared. We will prove that using this definition. Now, this circle is having a total degree of rotation is how many degrees? there are 360 degrees. 360 degrees over 360 times pi r squared. That's why it follows that the area of the circle is pi r squared. Okay, the total to complete the rotation of this, we have 360 degrees. Clear? So that is the area of the sector. The next is the area of the triangle. Area of the triangle is actually, okay, this is the area. Sorry, no, I was mistaken that the area of the sector is only this one. Now, the formula, the area of the segment, by the way, the red, is the difference between this area of the triangle. So next, we were able to define the area of the sector, which is this one. The next is the area of the triangle. So that when we get the difference of these two, we were able to get the area of these two area of the area of a segment shaded in red. Okay, so the area of the triangle is this one, right? This one. This is the triangle, correct? Okay, so the area of the triangle is having a formula of 1/2 AB sine theta. Clear? So continuing now, notice sir, where is your A, where is your B, where is your theta? Okay, from here I can call this A. This is the side A of the triangle. This one is the side of another line, which is the side of the triangle, and the included angle is what this one, which is 30 degrees. Okay, so it will be for A and B. What is A and B? Isn't it they are the radii of the circle? So we can replace now A to R, B to R, and then sine theta. Okay, this is theta here is the central angle or the included angle. Okay, take note of that term. Included angle means this is the angle formed between two adjacent sides. So this is the included angle, or sa circle, this is what we call the central angle. So now it will be summarized as 1/2 R times R. You will have R squared sine theta. Okay, now we will see what is the angle which is 30 degrees. So when we try to solve that one, 1/2 R squared times sine 30 degrees. Okay, so the area of the triangle there is, how much is sine 30 degrees? How much? Sine 30 is 0.5 in your calculator. Okay, the value of sine 30 is 0.5. Make sure that the mode of your calculator is in degree mode. Otherwise, you will not get the correct answer, which is 0.5. So this is 0.5, so it will be 1/4 R squared. So the area of the triangle is 1/4 R squared if the theta is 30 degrees. Clear? Now, so you have this one. Now we can summarize that the area of the segment is equal to 1/12 pi r squared minus area of the triangle 1/4 R squared. Okay, so therefore the answer should be this one. Okay, I hope you got the correct answer for this one.